like the dependency injection, like dependency management as well. It's just so great with Effect. I feel like I'm much more incentivized to write unit tests. And I don't know how other people think about engineers at companies like Zendesk and like Facebook and Google, like big companies, like how they deal with these things on a day-to-day basis. In the end, like it doesn't matter how skillful or experienced you are. It comes down to incentives all the time. Like you do things that you are more incentivized to do. So if a language or a framework or a library makes something really easy to do, you will do it regardless whether it's the right thing to do or the wrong thing to do.
Welcome to Cause and Effect, a podcast about Effect, the TypeScript library and ecosystem helping engineers build production-ready software. I'm your host, Johannes Schickling, and I've been building with Effect for over 4 years. With this podcast, I want to help others understand the benefits and powers of using Effect. In this episode, I'm talking to Attila Večerek, a tech lead at Zendesk and long-term user of Effect. In this conversation, we talk about the challenges of building production-grade software in TypeScript and how Zendesk ended up adopting Effect in one of their main products serving millions of users every day. Let's get into it. Welcome, Attila, to the very first episode of the Cause and Effect podcast. How are you doing?
Thank you, Johannes. I'm so happy to be here. I'm doing pretty well, thank you. How about you?
I'm doing fantastic. Really looking forward to doing this podcast and to do it together with you, since I think we've been in touch now for quite a while. We met like half a year ago, also for the first time in person at the first Effect conference in Vienna. And really excited to do this together and share more your story of like discovering Effect and using Effect. So you're using Effect at Zendesk, but would you mind giving a quick introduction of who you are? What is your role at Zendesk? What have you done before? And then we can dive deeper.
Sure thing. Hey everyone, my name is Attila Večerek, and I've been at Zendesk for almost 7 years. It's going to be 7 years exactly this year in October. Currently, I'm a tech lead at a team in the Guide organization, which is responsible for the help center part of Zendesk. So if you see any help center articles or community and stuff like that, that's what I do. And most recently, I also got the responsibility of revamping our customer satisfaction feature, which is one of our most used features besides like the core product, which is ticketing itself. And yeah, I'm very excited about that. And that's actually the feature which is built using Effect.
That sounds awesome. Yeah, I'm excited to hear more about that and go in depth. But would you mind describing a bit more, given that there are, I think, several thousands of engineers at Zendesk, and not all code there is written with Effect. That might change at some point. But would you mind giving a quick overview of what it means to be an engineer at Zendesk?
So Zendesk is really large. We have many sub-orgs or departments, and each of them, even at the team level, like there are huge differences. We're truly a polyglot company when it comes to languages and different kinds of tech stacks. I still think most of our code is still written in Ruby. The company started with Ruby and Ruby on Rails specifically. We have 2 large Ruby monoliths. Both of them I have to interact with from time to time. Yeah, that's always an interesting experience, especially when you've been working with Effect for a while and then you have to go back to Ruby. And I'm like, oh, okay, things are a little bit different here. But besides Ruby, there's also like a ton of Java, some Scala, some Golang, yeah, and obviously TypeScript, mostly for front end. But we have also some companies that we acquired who brought in a lot of backend TypeScript, and yeah, we have some of the TypeScript on the backend in Guide as well.
So it sounds like Ruby has always been the majority of code and still is. Is there any technology, any language that you feel like is really on its way in and might replace Ruby as the primary language maybe at some point?
That's really hard to tell. I don't think Ruby will go away ever. these huge monoliths, they're here to stay with us for until Zendesk will exist. I'm pretty sure of that. We had some initial thoughts of breaking the monoliths down, but it's really hard to justify these efforts when it comes to product and like the business needs of the company. So for all the startups out there, like if you start with the technology and you become like large company and really largely successful, all the tech that you accumulate for all those years, that's gonna probably stay there for a while. So yeah, maybe think about twice about what you start with. Not all these tiny decisions, but like the major ones. It's good to put some thought into it.
Oh yeah, for sure. But I mean, Zendesk is a very profitable and very great company. So I suppose it wasn't the worst stack decision if it led Zendesk to this point today. And given that you are also now leaning more into TypeScript, I think there's you can probably use the best tools for the appropriate jobs. But speaking of TypeScript, I think this is one example of like a theme that I'm noticing, which is that you seem to challenge the status quo a bit when it comes to engineering within Zendesk, where you see, okay, this is how things are done. And then you seem to send some ways to do things possibly better. And this is, I think, where you and some colleagues, if I understood correctly, have at some point looked at TypeScript and said, actually, this is a bet worth making. Can you share that anecdote?
Yeah, sure thing. So maybe just to understand for maybe people who are not familiar with Ruby and Rails, Ruby is a dynamic programming language. It's great for really one engineer or tiny teams that know the code base by heart. It makes them really efficient. So productivity wise, it's terrific. So starting with Ruby for Zendesk was definitely a good bet. It allowed them to have like a velocity in the beginning that was absolutely crucial to become successful. But working with a dynamically typed language, especially like with a heavy OOP focus, where you have lots of like design patterns. I'm not sure if you have worked with teams where people would argue like, oh, you know what, for this feature we should use this design pattern, and then the other side would be arguing, no, look at switch your mentality, like you have to look at the problem this way, and then they bring up adapters and whatnot and DDD and all these things. At a certain scale, it becomes fighting an uphill battle all the time because you have to be fully aligned with all the people who work on the code base. You have to agree on these things, like what are the design patterns that we are introducing? Okay, are we shifting to a different design pattern? Are we re-architecting, redesigning our modules? Are we taking out and extracting reusable modules? And how do we do that? Are we doing some module boundaries within Rails and use Rails engines or some other ways of enforcing these module boundaries? So all of these decisions, like you really have to pull the same rope in the same direction, and then it's good. But at some point, let's say you have this huge monolith, which we have, and you have 50 people or even hundreds and thousands of people contributing to it. Having this alignment across the entire organization is really hard. So what you end up having is a mixed bag of things, and parts of the repo use one design pattern, another part uses another one, and then there's this new design pattern that you're pushing for, some modularization, and then that's a migration. And then there's tons of migrations going on at all time, like 5, 10, 15 different types of migrations in a code base. And then let's say you're a contributor who just wants to implement like a tiny bit of a feature which is necessary in that repo so that the other service can communicate with it. I don't know, let's say you want to emit some events from the main monolith, and then over Kafka or over whatever message bus, so that you can consume those events in your microservice. Well, suddenly you see 5 or 6 different examples of how to emit domain events over Kafka. So what do you do then? How do you find the people that know what's the current status quo? Or will you just blindly pick the one that is the most prominent? I mean, there's no problem going with that route either, because if it's the most prominent thing, and let's say it's something that we're moving away from, you can just commit to that and it will be moved away from with the rest. But then, if you pick something in between, then that also brings the risks that the people who are doing that migration will just have bigger and bigger headaches because now they need to migrate different kinds of ways of doing things into this one way of doing things. So these are the biggest problems that I see with Ruby. Alignment, constantly fighting an uphill battle. You introduce a new feature, but at the same time you introduce a bug because you missed something and there's constant action at a distance. You change one part of the application, which has some unforeseen or unpredictable effects on another part of the application because everything is reusing everything.
That makes a lot of sense. So it rather sounds like you're running into some like social alignment issues where you just have so many engineers, like, and all probably very brilliant and with like the best intentions, trying to design it with their understanding of the world. But if you have thousands of engineers, this can lead to some very wild different directions. And to enforce that alignment, I think if you don't have a type system at your disposal to help with that, to be even aware of like, hey, here's like some divergence. We're unopinionated maybe, or we tolerate both, but even to have some visibility into this and help drive the alignment, I think this is where a type system can help a lot. And I suppose that is what has made you so interested in TypeScript.
Yes, absolutely. So that was one of the biggest driving forces behind the adoption of some language that is statically typed. It has tons of benefits, not just like this alignment. Very recently, I just actually had to go into one of these large Ruby monoliths, and there's a feature flag that I introduced and some different behavior for when the feature flag is enabled. And now this feature flag has been rolled out fully for some months now. So I was looking into removing the if else branch for the feature flag to keep only the logic that's basically used now that it's fully rolled out. And by removing that one line of code, I broke like hundreds of unit tests because the unit tests had no idea that there was like a dependency on some HTTP call somewhere down the line. So now I have to find like a place where I can maybe permanently mock this call to a specific endpoint for all the tests forever, because I cannot pinpoint like the hundreds of different places where this is exactly called. So I have to mock it like on a general level. So these are also kinds of issues that you bump into when using languages and frameworks like this, which is going to be another segue into Effect, I guess, later on with the dependency injection.
Yeah, most certainly. So it sounds like you're building production grade software at scale at Zendesk in many different flavors, many different technologies. But at some point, you've introduced TypeScript, and that's the foundation for the services and products you're building. What was that journey like? So you now have a type system to help with many things, but I suppose it still has not given you the silver bullet that makes it super easy to build production grade software. So, what are some of the challenges you were still facing and possibly still face today, and where you're reaching for effect?
So, if I have to reflect back on the time when we were introducing TypeScript at Guide for the first time, I think obviously what we wanted to avoid were all of these problems that come with shared monoliths. We just wanted some service which is nicely isolated, and we have our own deployment schedule, which is basically on demand. We don't need to deploy it on a weekly or bi-weekly cycles. And then, of course, the maintenance improvements, because now you have a type system. So if you make a change in one place, the compiler will aid you in updating all the other call sites. So that was obviously one thing. But we also wanted to make sure that we don't get into these like reliability issues that we were having with the bugs. So like type safety was really important for us. Then we're looking into how to, because there are many different ways how you can write TypeScript, right? Like you can be really lenient and allow any, right? You can typecast here and there. The language is quite flexible. You can use as much type safety as you want. or you can go towards the other end of the spectrum and use like the most brutal compiler options there are out there and make it super type safe. And then you even start thinking about, okay, how do we do end-to-end type safety, right? Because there are certain things that come out of your system, like on these boundaries of your system. You have a HTTP request coming in, maybe HTTP request going out, Kafka message coming in. Like you need to parse these, and at the inbound of your system, you have to be able to work with it with a static type, right? So how do you do all of these things? Rolling it manually is really tedious with all the type checks at runtime, especially if you have like really complex objects. It is really hard to do that. So obviously you can compose, like start at the leaves and then build up all of these, but it's a lot of work. So we started looking into other, like maybe even other programming paradigms, like with Ruby. Like of course there's like a ton of OOP stuff, but then with TypeScript we were realizing, oh, okay, maybe we can actually leverage like some functional programming concepts to build more composable software. Because one TypeScript service was not our goal. We were already thinking in multiple TypeScript services, and in the end it did become reality. And then we wanted to share code in between them. And then how do you do that? Well, we came up with a monorepo of different libraries that we can use that implement like Zendesk concerns, things like sharded database clients that know how to connect to our sharded database, and yeah, many other libraries like these internal ones, these productivity booster ones. So we started implementing those, and then we're like, okay, but they are like different libraries. Like suddenly they have, this library has this API, this library has another one. I want to use them in combination. And then you think about how to type all the APIs in a way that they nicely flow. So that's when one of my colleagues found FPTS, and that sounded really great. Obviously, it had a huge learning curve for us. None of us were really much into functional programming. I only remembered some stuff from university, but definitely haven't had like hands-on experience. And then learning FPTS, like people who learned it, they probably know how hard it is, because you don't have like real documentation. You have like API interface documentation.
What
And
gave
then
you the confidence to take the leap of faith to go to reach for FPTS and make that the foundation for your libraries?
Desperation, I don't know. I was just really, I think we all just wanted to avoid another monolith, and obviously we cared a lot about these tiny libraries that were meant to be shared across the different services, and different services need to do different things, right? Like they're in a different domain, so it's really hard to predict what API is the right one. So as long as we can stick to something and make it composable, that should work for most of the cases. I mean, that was at least our idea. The execution was rough. We were iterating on this group of libraries, and we followed a versioning strategy that would version each library at the same time. So even if we make a change in one library, we would bump the version of all the libraries, just to make it easier for the consumers to understand what version of one library works with another. So we opted for this. And then the iteration was so fast on these APIs, we just kept introducing breaking changes all the time, because we discovered new ways of using these libraries. And so within a span of 3 years, I think, we went from version 0 to version 27. Our consumers were not happy about this. Let's just say this.
Right. So I suppose FPTS at that point was already quite the pill to swallow for you all, where you convinced yourself to do it, but then to have other API consumers that did not intentionally say like, yes, we want to bring in FPTS into our life, but that's just the way how you offered it to them. That was probably even trickier. So, but that's what you started out with, and I suppose you chose that for very understandable reasons, such as the dream of composability and code reuse and making all of your systems more resilient. but it came at a price of like a rather esoteric flavor, particularly for the ones who were not getting up in the morning saying, yes, I want to do functional programming, but who just want to do proper programming, maybe in TypeScript. So, and if I understand correctly, this is where you have been kind of like running into growing pains of FPTS and building larger systems out of this. And at some point, you found effect. So tell me about that.
Oh yeah, so that's yes. So basically, with this FPTS, we were trying to build something similar to Effect. We wanted to have a system which allowed our consumers to do proper dependency injection with all the config that we provided, so that when they start their program, like if the config is wrong, it will just not deploy. We wanted to eliminate as many foot guns as possible. Obviously, resource management was another big thing that we were looking into. Like, how do you properly handle like all the interrupt signals coming from Kubernetes when it's trying to kill or restart your container? These things, they require a lot of effort, and they're not easy things to do, especially if you want highly composable solution. So I think one of my colleagues was my partner in crime when it came to introducing FPTS to the organization at large. He found Effect. I don't know how he found it, but he found it. And it was maybe in 2021. I don't remember. I'm so bad with years, especially because it was like the pandemic there, and suddenly like 2 years felt like one or a half. Yeah,
Yeah.
but around that time, it was weird. Time flew differently. But he did found it, and it wasn't like we were jumping on it immediately, because at the time there wasn't really such a huge buzz around it like it is nowadays. Also, didn't have a stable API, so we were, for about at least a year, we were mostly observing Effect from the sidelines. We didn't talk to anybody. Yeah, exactly. It was just another FPTS for us from the sidelines looking at it, but it looked way better than FPTS. It looked like, okay, this is not just abstractions. This is also some implementation, finally, something that makes our lives easier. It's like a general programming framework, how to build like resilient services, and all the dependency injection, resource management, configuration management, building the layers of dependencies. That's all taken care of for you. So that looked really promising. And as I mentioned, like for a year, we were just looking and watching Effect and its development. And then later, when it felt like, okay, now it seems like it's like stabilizing around some sort of an API. We still don't really agree with some namings of some concepts, which then also changed name and everything, and now it's like much better. But we were that's when we started to seriously consider adopting it on some project. We didn't really know which project should it be. We didn't really want to go right into the migration of an existing FPTS project, because we didn't know how to do it. It was a little bit weird because from FPTS we had all these reader task iders, and we could intuitively see how it would map to an Effect, but we didn't quite understand how it would work with our flavor of FPTS, if you know what I mean. Like, we built those abstractions for managing dependencies and resources and whatnot. Like, how would we make the step from that to Effect? So what we ended up doing in the end, my team got this opportunity to rebuild the existing customer satisfaction feature, and we are making it like more flexible. Like, it's almost like on our end, in the backend, we treat these customer satisfaction surveys as generic surveys, because like, what is a customer satisfaction survey? It's like you ask a bunch of questions, and one question has to be how satisfied you are about whatever you're measuring against. In our case, like satisfaction about how your ticket was handled by the support agent. But in the end, it's just a survey. It's a bunch of questions and different types of questions and whatnot. So it looked like a perfect opportunity for us to try Effect, especially because there was already like Team Smart's SQL package, SQL Effects, which is like the predecessor of Effect SQL. So that was really good because our service needs to interact with the database for sure. So that gave me a lot of confidence there, obviously. And now we're using Effect SQL. I'm trying to like be in lockstep with all the development with Effect itself, the core library, and then also like all the satellites, the level one or layer one abstractions.
So it sounded like this was like the initial prototype where you gave Effect, or like the initial trial project where you went from observing the Effect development to actually getting your hands dirty and seeing, okay, is this fulfilling all of our dreams? How our world already got better through FPTS, but we've introduced a couple of like new problems, and maybe some of our teammates or some of the other teams have a hard time with it, and that could be addressed by Effect. And so now you've adopted it. How did that go? How quickly were you up and running? How quickly were you productive? And also, very importantly, what did other teams think?
So before I actually get into that, let me just tell you that for us, getting rid of FPTS or moving towards something else was existential. Like there was no universe where we would be able to push for FPTS, at least in our usage of FPTS in the way we did, at a larger scale. Like if we wanted this TypeScript service framework to fly and be useful for not just our two teams that used it, but also outside of our org for all the TypeScript native teams who we acquired through the business deals and stuff. We really had to get rid of it. We had to find like an alternative. And unfortunately, there was like no real alternative beside Effect. But I'll get into why this is actually a pretty good alternative also for teams that only use native Node.js and TypeScript. But yeah, so after I tried Effect for the first time, so I think it was last year in June that I made the first Effect commit ever at Zendesk. Getting up and running was fairly easy because I could get a skeleton of an application using our FPTS based service framework. And then, yeah, I think one important thing that I need to mention is that we're mostly building these services on GraphQL, and then we have GraphQL Federation. So we have like lots of microservices, each owning their own domain, and we call them subgraphs, and then they compose into a supergraph through the Apollo Federation solution. So this survey service was just another subgraph. So once I got to the point where I could start implementing the resolvers for the different GraphQL objects and mutations and queries and whatnot, I was already at that point I could finally use Effect. So I was using Effect in the beginning only at the resolver level of my application. So that went pretty well. Startup was very easy, and then obviously like I created like an application skeleton that I'm familiar with, and then the resolvers were Effect, and that nicely adapted into the promise-based resolver, because with an Effect you can run it as a promise. So that was perfect. And then after that it was just like, okay, let's start with this. Let's start with a simple effect. Let's start with a dummy resolver. And then next step was let's add some validation. So we brought in effect schema. And yeah, now that I mention effect schema, I think that's probably the best gateway drug into Effect. Like everybody needs input validation. Everybody. It's almost impossible to imagine a piece of software like an HTTP service that doesn't need input validation. Unimaginable.
Yeah, I definitely agree. I mean, this is why Zod as a standalone library is also getting so popular. But I think people will see that their requirements will grow beyond just input validation, where you maybe need to run some effectful code, like some code that can go wrong, etc., as part of this validation. But then also critically, not just parsing and validating the code, but at some point you might also want to re-serialize it, as you don't just receive data, but you want to ship it over the wire to another service or to your front end. And then you're scratching your head because, okay, you have now this beautiful SOD system that can validate and parse data, but now you want to go the other way around, and that is impossible. And if you use whatever, like you've created a class, a user class that you parse things into, and now you have your data expressed through like those classes or more complex data structures, and you want to call JSON.stringify on it, and suddenly stuff blows up. And this is where effect schema comes in. And I completely agree. This is going to be my primary bet for what will be the main gateway drug that brings people to effect. And it has gotten so nice. I think this is where in the past where you've been using FPTS, you probably used IOTS. Effect schema is written by the same person, but I feel like it's sort of a new incarnation of the same person who just made everything so much nicer to use, so much easier to understand. So yeah, huge fan of that part.
Absolutely, same. I'm a huge fan of Julio, who does all of this work. It's just amazing how much.
Big shout out to Julio.
Yeah, absolutely. FPTS and IOTS helped us so much in the beginning, and now seeing him also do all of the work for schema at Effect and doing a lot of Effect documentation work as well, it's just it's amazing to see that.
So it sounds like last summer, you've written your first Effect code at Zendesk. And I think by the end of that year, you've been getting to a point where it could be rolled out. And we've been just chatting before where you mentioned that this year it's getting released in GA. So I suppose across like all production traffic, etc. So how's that gone? And how did your team like it? How was your experience?
Yes. So my personal experience was great. Let's start with me, and then we can go to the team, and then we can go like outside of the team. Yeah, I was taking really baby steps with Effect. So after input parsing and validation, the next big step was to interact with the database. Obviously, relying just on SQL effects was not enough because we have a sharded database. We have like this big shared sharded database instances that every application interacts with. So we had to write like a wrapper for SQL effects that would read the configuration, create one SQL pool per shard node. So basically one for a writer, one for a reader. And then we would have like this big collection of writers and readers grouped by shards. And then every time a request comes in, we would have to figure out what is the shard ID, reach into the collection, handle like shard not found errors and stuff like this. Finally getting the shard, getting the pool for the writer or the reader that you currently need at the point where you need to like call the database. And then that's when we get the SQL effects, like the SQL client from the library at the time. Like the pool is basically provided by that. And then that was great once we got there, because then we could persist events. So one thing that I want to mention is like we use event sourcing, where exactly this two-way bidirectional schemas work really well, because on one hand, like when the request comes in, we do the input parsing, and then that input represents almost the exact payload that we then write to the database, which represents our event. So once we did the parsing, obviously we need to serialize it into a string that we can then push into a text column in SQL. So yeah, that was a big thing. And then obviously the next step after the database client, there was like the HTTP layer, where we might need to call like different HTTP services, especially around the feature flags and stuff like that. So yeah, really baby steps. And then eventually we added some level of observability, logging, tracing, metrics. In the beginning, it wasn't really anything sophisticated. We were relying mostly on the Datadog tracing library defaults, which provided some level of detail. It didn't work very well. We didn't get very detailed traces, but it was good enough to see some traffic and what's going on at the, maybe let's say, the GraphQL level. So everything that is an effect, obviously we couldn't get any visibility into that, but then we switched to OTel eventually, and then things improved from there. And then the more I learned about effect, the closer I was getting to turning the application into an end-to-end effect. And today it's like fully effect. So it's effect from top to bottom.
Right. And I think this is a pattern that I've seen a lot, both in the apps that I've been building and where I've taken my first steps with Effect, but also in what I see how other people are approaching Effect. Is like how nicely it can be adopted incrementally, where if you think about your program as a tree, you can very easily start at like any layer of the tree, really. Like at any position, you can start out with the leaves and write those as effects, and then at some point just run them as promises. And assuming your other code is already like promises or async await based, you can just call your new effect code as good old promises. Or you can do it on the other way around, and at the root of your program, you can rewrite some parts that are maybe more for governing and overseeing the execution of your program. You can rewrite that with Effect, for example, request handlers, but then still call out to promises, and everything else of your program is still promises. Or you can do it somewhere in the middle and say, okay, at some point, we're like in async await, we're going to rewrite some part in with effects, but then the stuff way further down we'll call again as promises. And so you can mix and match as much as you want. But what I've typically seen is that people get very productive very quickly with like some incremental adoption. And then they see like, oh, wait a second, that part is still not as nice. And that is some of the leftover promise code. And then in no time, that's rewritten to effect as well. I think what is typically the case is the more you rewrite to effect, that kind of collapses the amount of code, typically like by half, and shines a very bright light on some of the holes that you haven't yet covered, such as error handling. Very often, like Effect kind of shows you a mirror and like asks you, like, hey, here stuff could go wrong, right? What have you done so far about it? Not really much. And so it forces you to do the right thing. That sounds very familiar, what you've described.
Absolutely. Writing effect has a lot of knock-on effects, pun not intended, on how you write maintainable code on a day-to-day basis. Things like, obviously, the error handling, it's amazing. Very recently, I implemented a Kafka consumer with effect using Kafka.js. So I just wrapped Kafka.js in an effect API, and then had like an abstraction for a consumer, and then obviously the consumer can consume things either message by message or in batches. So I just needed a message by message type of consumption. So that's what my abstraction does. It creates a consumer, and you pass in like the effect that a function that returns an effect that handles like the incoming message, the payload. It was just really beautiful to see how the different error cases all bubble up to the very root of your message handler. And then in Kafka, like when you consume the messages, it's super important to make a decision at that point. Like, do you drop the message or do you reprocess it, right? You need to be able to make this decision for every single error case. And, you just have effect that catch tags, and then you have like a big dictionary, like a big object containing the tag of the error on the left side, and the error handling basically die or succeed with some error logging or whatever. So if you die, Kafka will reprocess the message. If you succeed and you log it, then well, you can either put it into like a dead letter queue or something if you want to keep those messages around. But if that's not necessarily important because it's like time sensitive, and if you don't process it now, then it doesn't make sense to process it like 5 days later, then you just discard the message. And before, I would normally implement Kafka consumers like in Ruby or maybe in FPTS. It was better, but I don't think I had it to this level of granularity, because what we ended up doing in FPTS was taking like the shortcut route where we would just return a generic error interface just to have like, it can error, but we didn't know what kind of error. Later on, as I got better with FPTS, then obviously we would have different types of errors which would also compose. But I haven't written a Kafka consumer with that approach in FPTS. But with Effect, it was just like so easy, and it's so useful because you don't think about all these different kinds of ways your program can fail. And my consumer is very simple. It receives a message, it parses it, writes an event, and then calls another service. So basically 3 things. But there's like 15 or 20 different ways it can fail. And it's just like, wow, now I know everything, every single way how it can fail. So what took me the most time was thinking about whether to discard or reprocess the message in the whole implementation, proportionally the most time.
But that makes a lot of sense. And I think that makes the difference between resilient and non-resilient software. I think a lot of TypeScript programmers are blissfully ignorant of the unhappy path of a program. But this is what ultimately makes your users very unhappy. If stuff goes wrong, and a lot of times that is completely unrelated to whether a user has done something wrong, as whether your servers have a bad day, or whether you've migrated some infra and like some things is like hitting capacity, or you're just hitting a blip somewhere and things go wrong and a user gets like an endless spinner or gets like undefined is not a function in their face. This is where like some backend engineers haven't done their homework. And I get it. It's really tricky if you're just like dealing with like catch error and then you have an any or unknown thing. And what do you do with it? Yeah, maybe you bubble it around, maybe you log it, but to work with it as nicely as like structured type data that you return from a function, that's what you get with Effect. And you can handle it so nicely that it's actually fun to deal with the non-happy path.
Yes, and I think you touched upon it very well. It's fun. You don't feel like it's something that you have to do, but the language or the library like doesn't really provide a good way for you to manage, and then it's like just a headache. It's really fun to handle these cases in Effect, and it just has such a great effect on uh, on your reliability, on the reliability of your software. The other thing that I noticed was also in terms of maintainability and like, testability, like the dependency injection, like dependency management as well. It's just so great with Effect. I don't have to worry about mocking things extensively. I just build a fake dependency and provide that instead of the real one, the live one. And I feel like I'm much more incentivized to write unit tests. And I don't know how other people think about engineers at companies like Zendesk and like Facebook and Google, like big companies, like how they deal with these things on a day-to-day basis. In the end, like it doesn't matter how skillful or experienced you are, it comes down to incentives all the time. Like you do things that you are more incentivized to do. So if a language or a framework or a library makes something really easy to do, you will do it regardless whether it's the right thing to do or the wrong thing to do. It's just like this. I don't know if there's like a law for this, but it's definitely a psychological effect.
This is one of my favorite paradigms or guidelines in programming or in life in principle, which is like make the right thing easy. And that is, I think, Effect makes some really hard things that are the right thing as easy as they can be, and so easy that it's fun. Doing things like error handling or structuring the hierarchy of your program in a nice way, in the as nicest way as you could possibly do it in TypeScript, that's a huge lift. And that's what Effect enables you. And I think something like dependency injection, that's probably, if you're in your Effect adoption journey, that typically happens sort of like maybe in the second week when you're using Effect after you've like rewritten a whole bunch of like promise code, etc. Maybe you've now like finally cleaned up some of your tech debt around error handling. And then you realize, okay, there's still like some global state we mutate to kind of pass things around, or we just have like this big blob of like properties we're like kind of pulling through like all of our function invocations. Or maybe we have this like monstrous context object, which maybe has a whole bunch of like, either it's untyped or it has a whole bunch of like nullable properties, and you kind of pray that it's there. That's like all like semi-principled. I'd argue the most principled approach about that is like having like a bag of properties that you just like lift through your function calls. But Effect gives you the best of both worlds. It gives you a very principled approach and a very convenient approach. And I think dependency injection has kind of a bad rap. I've used it in various programming languages. I've used it like a lot of in PHP in the past. I've used it like in Golang and other programming languages. It felt like, okay, this is how things should kind of, there is a solution somewhere there, but all the solutions I've used so far were kind of like had such big foot guns that at some point I said like, okay, no, I've hurt myself too much with that. I'll do it manually. And I think Effect finally gives you the cake and lets you eat it. And I think that's really hard to explain. And I think you have to build a little thing, refactor it, and like then throw in a little bit of like type safe context, which is all there is to it, really. It's like React context, but type safe and much nicer. So that's, I think, something you have to try for yourself to see that how nice it is. But I agree, this is one of the best things about it.
Yeah, absolutely. And why does it have a bad rep? If I think about it, I think it's again comes down to incentives. If the language makes it hard to do dependency injection, because it's never just a singular case like, oh, I'm going to do dependency injection on this function, and this one function will be, written the right way. Well, your program usually has a certain depth, like there's like a function, and then that function calls out other functions. Those functions call out other functions, and then the dependency needs to travel all the way down because it's called somewhere at the leaf. For example, a database call is made somewhere at the leaf of your program. And wiring through all these layers and then adding the dependency in the list of arguments all the time, well, I'm not surprised that people get tired of it. And I started thinking about it a few weeks ago, like, what are these approaches? And I started calling them just internally for myself, for my own sake. Like there's this explicit dependency injection where you like have to do all the wiring like yourself. Then there's some languages like Scala, which somehow give you like some language features which allow you to implicitly wire through
Right.
these
You need to
things.
have a big brain for that.
And it feels a little bit magical, right? This implicit dependency injection. I don't know if it's through traits or something. I'm not a big Scala user, but I did see some of it. And then you have Effect, which is like, it's somewhere in the middle. Like it's kind of implicit, but it's also very explicit in a sense. Like you do declare, you see where you inject the dependency by providing the implementation. And then you also see the place where you're calling the functions and the stuff that's on the dependency, because you have to yield it, or yield star. So it's kind of implicit because you don't have to wire it manually. You just use it at the site where you need it.
I think it's the best of both worlds in a very similar way how I think TypeScript is the best of both worlds, where it very elegantly does type inference in most places where you can. A lot of static languages like ask you to write type annotations everywhere. And that I think also causes like some fatigue when you use a typed language. And I think TypeScript makes it so nice that you can get away with like just type annotations in the minimum amount of places, sometimes even for argument types if you have a default value, for example. So most things where possible can be inferred, and that's totally fine. And so think about the context, the type dependencies of an effect of a function. Think about it the same way as like if it's used, it can be inferred. If you return something from a function that looks like an object with a property user, then the type can be inferred. That's because you return it. And what's so cool about effect is like if you use a thing in a function and using, like you said, like if you yield something, so the equivalent of like an await, then effect and like A on the type level wires things up nicely with TypeScript, that in the type signature you say like, aha, here we need the database client. And also during runtime, makes sure, like, okay, there's behind the scenes a context object where we have the database client, so it picks it up. And not just even that, but also when you finally get to run your program, it makes sure that at some point you supply your database client. And I think that is so elegant when you use it. But it's hard to kind of grasp it if you haven't taken a look at that with code and like try to refactor a little something. But I agree, it's one of the most elegant things about Effect.
Absolutely. People just have to get their hands dirty. There's no other way of learning and understanding Effect. Like, obviously, you could read the documentation all day long, but then you get fatigued because there's just so much that Effect provides. I often see people being very confused about, what is Effect? Like, I don't understand it. It's just, it seems to do everything. Because it's such a big departure from the tiny libraries with very well-defined responsibility in the JavaScript ecosystem. And then you can like pick and choose, and you can build your own tech stack upon certain libraries. And then that's your definition of a production grade software. But then you have Effect, which seems to be like the glue code. It's a really generic programming framework.
Right. And I suppose in a parallel universe, Effect would have been a different programming language. But I think now we sort of have the best of both worlds in that regard as well, because TypeScript is darn good. Like, and so many people already love TypeScript. I love it. It has so much traction. It has so much amazing tooling around it. VS Code just works super well with it. You have like LSPs that work in other places. So at this point, you need to have a very good reason to create a new programming language. And I think good reasons could be the superior runtime performance, what like Rust is giving you, or what other programming languages give you. But if you can't provide those unfair advantages, then I think you got to stick with TypeScript for now. And TypeScript is so elegant and so flexible that you can bring all of those semantics that you would get from something like Reason or Rescript, but you can bring it directly into TypeScript. This is where what Effect has struck this really nice balance. But I agree, you need to rewire your brain a little bit, and people maybe don't immediately get it. And I've seen an interesting correlation that people have the easiest time getting what Effect is about if they've experienced the problems that Effect solves before. And they have sort of like a lot of scar tissue from trying to solve those problems themselves, like trying to do proper error handling, trying to do observability, trying to do interruption, what you've mentioned before with Kubernetes. So the more problems an engineer has experienced in the past, particularly a TypeScript engineer, I feel like for them, Effect clicks most quickly. But yeah, I'm curious, what was the experience talking to other engineers at Zendesk so far? What have they been confused about? What has clicked for them?
So far, I mostly talked through my own experience. Then I had my immediate team members, and with them, obviously, it's a journey because they have to learn it. It's also different from FPTS. Also, FPTS, they didn't really bother learning that much. Like, as long as they could kind of understand in terms of the code review what's going on, that was already a good enough level for them to be productive and help me with the reviews if I write some code. Also, my team in the past 1-2 years, like we've had this unfortunate situation where we had some churn in the team. So often I was like the only backend engineer on the team while being the tech lead as well. So I really needed like my front end engineers to be able to review my code. And Effect is just doing really well in this regard as well, because once you have the generator syntax, where you have the gen and yield star, which you can easily map in your mind to async and await. You can build up this adapter layer in this mental model for you. Once that clicks, it's very easy for them to review code. I'm not talking about stuff like database queries and how to set up proper indices for your table and like these backend concerns, purely backend concerns. But like all the business logic that you write on the backend, and there's a ton of it, that's not an issue in terms of reviews.
Right.
So
that's sort of like the
yeah.
10-second onboarding. Like, hey, this stuff gonna look a little bit weird. Just everywhere you see yield, think that's await. Everywhere you see that gen thing, think that's async. And you should be able to like just read that code as like your traditional async await code. Go. I think that is sort of like the Hail Mary 10-second onboarding where someone can get really far.
Yeah, exactly. And that's like totally Pareto. Like this 20% of effort gives you 80% of the results. Like after that, obviously they're gonna have questions like, what is this layer? What is this runtime? What do you do when you catch tags? What are tags? Like there will be questions like this, but they require maybe more nuanced explanations, not just like a one-to-one mapping from a new concept to a well-known, well-established other concept. But it's that 20% of the productivity that you're achieving with the 80% of the effort. So already with the 10-second onboarding, you're so far ahead that the reviews just work already. And then
I like this idea of like exposing someone to effect first through like reading code and doing code review, since this is where someone through the context that they are already familiar with, maybe through a refactor, maybe through a new feature, they have all of the context that they need to understand what the problem is about, and now they can focus on the implementation. And I think what's also so nice is depending on where someone reviews the code, possibly ideally in their IDE, this is where you can also use all of like the type inference benefits to help you understand what's going on. If you hover over an effect and see like, oh, this is where we can have an error that is about maybe the user wasn't found, or maybe another service is down. This can add so much to the picture to understand what's going on, where before everything was just like an implicit sort of vague thought. And I feel like this is where someone, just by also being exposed, can pick up so much. And then you have seen, at the end of the day, a lot of code users are very similar to each other. And this is when someone now takes that step to writing their own effect code. They probably have already seen 2 or 3 places that are very similar. So you can go copy some of that code, go over there, adjust it, and bring their usual programming muscle. And it's going to work just as well and probably even better since you have improved type safety.
Yeah, absolutely. Also, I really love the way you can work with generators, because anything that's within the function body of a generator, it's basically your happy path, because all the error cases just short circuit the happy path. And then you just do a quick pipe after the effect where you handle all the possible failure cases. And I don't know why, but I just love this style of writing programs. Here's my happy path. Everybody can understand what's going on. And then now, in this pipe, I'm going to handle all the errors.
Right. This is where you can like sprinkle a little bit of like extra sauce on top of it, where you can, I often do also like timeouts there. I add a little bit of like OTel instrumentation around that, or maybe do like a retry for an error. But yeah, as you say, like in the generator, this, and I think this is so beautiful about it, is like you can nicely separate sort of like signal from the other stuff and say like, okay, here's my business logic, and here are those other concerns. I think like in the future, if we have like a next generation of IDEs, etc., and maybe like even more AI assisted, maybe that can help you and say like, hey, hide everything that is not about the business logic, or hide everything that, or like highlight everything that is about concurrency, or highlight everything that is about error handling. With Effect, you already put in sort of like the structural effort. And I think we're going to see some big rewards even beyond what we have right now.
That's very interesting. I never thought about this, but it makes a ton of sense. Yeah, the tooling that you can build on top of these like static descriptions of a program is just like limitless. Yeah. Interesting.
Yeah, this is something I'm very excited about, and we talked briefly before about the launch of the Effect Playground. I think it's super nice to have like an environment where you can just play around a little bit, get familiar with something. I use it on a daily basis to maybe understand an API surface a bit better and just play around with it, have fun. And we also threw in support for some of the Effect dev tools in there, notably also the trace viewer. And this is where you can get real-time feedback for what does it mean for my program to run. This is where maybe a certain thing took like a second and then should time out, etc. Like visually see what's going on. There's so many tooling possibilities that are coming, and that's gonna just kind of like the gift that keeps on giving. It's like you adopt Effect, and there's like so many benefits that just fall out of that. I think we're still at the beginning, and it's already very rewarding for, at least in my experience and what I've seen so far. So you shared your experience using and adopting Effect, and also how you helped your own team adopt Effect and be productive with it through code reviews and helping them to refactor code and build new Effect programs. But given that you built this service framework that is used, I think, all across Zendesk when it comes to TypeScript code, there's now more and more people that are exposed to Effect. So how was their experience? Maybe you got a little bit of like questions. What is that thing? Maybe some similar concerns that people asked about FPTS. So which sort of questions did you hear?
Yes. Well, that's a great question. So let me start with another team, not my team. That's the closest to our team. And they have some services that are fully written in FPTS and using our service framework. So they're looking and watching us from the sidelines, writing Effect code, like, because we're enjoying this opportunity of building a completely new service from scratch. And they weren't so lucky, so they're still stuck with their FPTS project, and they're just looking at us and are maybe a little bit jealous of us that we're writing Effect already, because they've been looking forward to writing Effect as well. But I'm helping them try to figure out how to migrate FPTS to Effect also incrementally. It's a bit tough, especially if you have your own abstractions and own ways of doing things with FPTS. So it's really slow, and also it's really hard to justify to spend the time to fully migrate a rather large project in one go. So it really has to be incremental. So that's a positive feedback from them. But then we also have teams that are outside of our immediate organization, and they are, let's say, more TypeScript native teams, and they have completely different requirements from my team and from the other guy team, because Effect was not their choice. It was our choice for the TypeScript service framework, right? And the service framework does provide a lot of value, but without knowing Effect necessarily, or FPTS even, it's really hard to tap into that value and use it immediately in your project, which knows nothing about FPTS or Effect, and the engineers know nothing about FPTS and Effect. So here, Effect actually brings some really good tools that can help bridge between the two requirements, and that's the adapter layers. So basically, when you have an effect, you can run it as a promise, or you have a promise and then you can wrap it into an effect using different APIs. So in our service framework, this is something that we're going to be leaning on more and more, because we want to provide the benefit to all the users, regardless whether they choose Effect or not. So for every Effect API, we can have a rule that we will also build a promise-based API, which is fully built on top of the Effect, because we're just going to satisfy all the dependencies at the time and run it as a promise. And then they can always look up what kind of failure modes there can be, because they can just follow by convention, or by inspecting the implementation. They can see which Effect APIs, rather which service framework, Effect-based service framework API is wrapped, and then discover the type signature there. So that's one way how they can reap the benefit of knowing what kind of errors there are. They don't have to inspect all the depths. I don't know how even people were doing it with like regular TypeScript libraries. How do you discover what kind of errors you may encounter? Like,
I
do
think
you?
typically you don't, and you discover it during runtime and logging.
Yeah, exactly. It would be so nice to know, like, oh, here's the documentation page. It lists all the 150 ways of my program failing or my library failing. But this doesn't exist. At least I have not seen a library documenting their implementation or their APIs to this level. It would also be really terrible to maintain the documentation for this.
Well, I mean, we have the perfect primitive for that, which are types. And I guess more modern programming languages such as Rust, etc., they have figured this out and they return results in case something can go wrong. And I mean, effect is about the same idea that you don't just return just the success value, but also you return the errors just through the return channel as other things as well. But coming back to the point you were just making, I like that approach that basically for the folks in your organization who are already excited and interested about effect, they can already start consuming the effect APIs. For the ones who are still on the fence or are not quite ready to make the jump yet, they can still stay in the promise land and need to deal with errors, etc. The good bad way, the old bad way. Which sort of questions do you typically hear when someone is confronted with effects? I suppose there's a full spectrum of people. You immediately get it and are excited to dig in, to people who are maybe curious but don't quite get it. And then maybe people who are much more skeptical. And maybe this reminds them of like some other bad time they had in the past and why they have reasons in mind why they don't want to adopt it. So tell me more about the different kind of reactions that you've seen.
Yes. So I've done a few effect-related presentations at Zendesk already. I presented at our annual tech conference in May. So I had the opportunity to actually get some of those questions. And lots of people are actually skeptical, maybe due to their own experience with something similar that they tried, or just it just looks too functional for them and they're more familiar in the OOP and dynamically typed languages. They don't necessarily understand it. Like at Zendesk, we have lots of engineers who have experienced all the issues related to scale, maintainability, testability, reliability, all these things. But still, this alone is not necessarily not a huge selling point for them necessarily, because they already have their ways around it. Like they have years of experience doing Ruby, years of experience doing whatever, and they know their way around it. Maybe they don't even care necessarily about super reliability, because there's like feature flags, so you can basically not break everybody at the same time, but you just break a tiny bit of the customers, which is understandable if you don't have any other option, because you're limiting the blast radius. But it's also not something I'm really a big fan of. Like I really want to catch the errors and possible failure cases even before I commit my changes. Like that's the ideal thing. I don't even want to push it somewhere to a CI and then waste CPU cycles of a CI just to make it fail. And then rinse and repeat many times possibly, because also sometimes it's really hard to run all the things that the CI runs locally due to different limitations. But yeah, so we have these people who know their way around. So for them, maybe a bigger concern is usually, okay, but listen, we have so many different technologies at Zendesk. We have to consolidate. Like, why should this be the thing that we consolidate on? How will you align with all these hundreds of engineers on this single one technology? Obviously, we have some processes like ADRs and whatnot, but if it comes to a big change like this, obviously there's going to be also resistance, because people just are accustomed to their status quo, their way of operating, and they don't necessarily want to switch, which is totally reasonable. And I don't want to change anybody's mind, or I don't want to force anybody to now, forget about promised land and start incorporating effect into your code base starting tomorrow. I truly believe it should be like a choice that everybody can make for themselves. But then you have, the company incentives to try and consolidate, to not go into too many directions, because if you want to be productive at the top level, at an organizational level, like the more people pull in the same direction, the better you are, and the more productive you are. So these are also a little bit political, influence, and political, the question of politics as well. Like, how can you influence without being in a big leadership position and stuff like that?
Have you found some arguments, like from the many things that effects can offer, that has resonated still with the people who are more on the skeptical spectrum?
Yes. So sometimes I do, because let's say you're a company and then now you had this financial crisis where the interest rates went up, and now you figure out that money doesn't grow on the trees, and you have layoffs and whatnot, and suddenly you stop backfilling for positions, which came up because of churn, and you stop hiring, so you have a hiring freeze or whatever suddenly. But the expectations of productivity are staying the same, so basically you have more workload per person. That's the final result. The company still expects you to deliver, but now you are fewer people to do so. It's a hypothetical one, right? So what do you do? Well, I think TypeScript is positioned really well, because you can have TypeScript both on the front end, which in many cases you do, and then you can have it on the back end as well, which isn't a terrible option, especially like, you have Node.js or Dino or whatever. Node.js with its event loop runtime, perfectly suited for IO heavy operations. And as far as I'm aware, like 90% of what Zendesk does is IO heavy. We take a message, no matter where it comes from, we do some processing, and we send the message somewhere else. Like maybe it's like you store a record in a database, or you emit a thing in Kafka. Maybe you have like a MySQL connector with Kafka, so you can do these things in a single transaction. So basically, you manage your distributed transactions this way. So you do a ton of like taking things from here, pushing it there. A lot of waiting time, a lot of I/O. What do you do? Like with Ruby, obviously, and this is another thing that I often mention, is cost. Like if you have Node.js handling traffic, like large concurrent traffic, heavy traffic, you can save a lot of cost, because with Ruby, what's your option there? Well, yes, you can use threads, but then your memory consumption goes up, because threads are not for free. Or you can scale horizontally. So when you put a horizontal pod autoscaler, max it out at 24 replicas or whatever, you figure out the rules around how to increase the replica count, by how much, when, what is the signal that you're looking at. You can figure out all of these things. Or you can just have a few replicas, maybe one per availability zone, or two per availability zone for extra redundancy of a node process. And then suddenly you have a throughput of tens of thousands of requests per second. So it's also money, So when you talk to to the leadership, you have to convince them with some hard hitting facts. And it's not just, obviously you can say, in theory, this works. No, you have to sit down, do the analysis, maybe set up some project which can demonstrate how much more cost efficient it is compared to other similar workloads, put it into money values, right? Convert it into dollars or whatever, and then show the difference. And then once you do this, you won the golden ticket or something, because it comes down to money in the end, always.
Yeah, totally. And I agree with that approach that you can basically like let the actions speak louder than words, and you're doing the right work already. You are shipping things in production. You're appreciating and leveraging all the benefits that Effect provides to you. And I think your team and some other peer teams have a great experience already with Effect, and I think those will show the results, and that might make a case for itself and prove out that it's not just words, but it's actually an improved reality that makes teams more effective, more efficient, happier, and possibly also then saves resources and money when it comes to running those services, saves downtimes, etc. So I'm sure the more time continues, the more all of those arguments going to resolve themselves in your favor. And I applaud you for being on the early adopter train.
Thank you. I do hope that it plays out really well. I'll do my part for sure.
Perfect. So maybe that leads me to the last question that I'd love to hear your thoughts on, which is what gets you most excited about the future with Effect?
Yes. That's a good question. I haven't put a lot of research into Effect Cluster, but it's definitely something I'm observing again from the sidelines and look forward to using in the future, maybe for some use cases like backfills. Let's say I have my event sourced service and now I evolve my event schema from version 1 to version 2, maybe to version 3. And now I feel like, okay, my switch statements where I switch between the versions of the schema and then the way I'm reducing the events into a single aggregate, it's getting a bit cumbersome. So let's just migrate some of those old schema versions to the latest one. So having like millions, maybe billions of records, it could take quite some time to do this sequentially. So having like a solution where I can have set up some workers which can agree on, the scheduling and how they're going to partition the database table among each other, and do it in parallel, that would be just the perfect dream come true. I don't want to start the backfill in every cluster one after another, or even in parallel, and then like having to like watch tens or dozens of monitors to see the progress of each individual backfill on every Kubernetes cluster, and then managing that for hours. Now, if that could be like maybe a 10 or 20-minute thing, that would be just the perfect dream, right? So I'm looking forward to clusters.
Yeah, me too. This is one of the, as I said, like gonna be the gift that keeps on giving, and we're gonna have like many layers built on top of the foundations that we already benefit from, and the effect cluster and the effect workflow primitives that are in the work and the systems that are in the work. I think that's gonna, that's gonna be literally next level. This is gonna unlock some benefits that you see from systems like temporal IO, not the new time standard, but temporal IO, which is about durable workflows and workflow scheduling and running long-lived things. You can already do that in Effect combined with temporal, but Effect is the perfect foundation to do that natively with the Effect primitives. When you think about rerunning something if something has failed, scheduling some work, processing work across multiple workers in massively parallelized systems. This is where we have like amazing foundations for that, and that's being systematized with the Effect cluster and Effect workflows project, which is now in development for, I think, also like in research for a few years now, and I think it's alpha grade right now. I think some people are already starting to use it. I'm actually also planning to give it a shot soon for the music app that I'm building. And I think it will take a little bit of more time to be fully production ready, just because it's also a very ambitious project. But it's very principled, and I'm very excited about the potential for it. And I think we're going to hear a lot more about that in the months and years to come, and possibly the next year's Effect conference already. So yeah, super excited that you're excited about that, because I think you have some really interesting use cases for that. So Attila, thank you so much for taking the time today to doing the initial episode of the Cause and Effect podcast with me and taking the time. So that's much appreciated, and thank you so much.
Thank you. It's been a great honor to be the first guest of this amazing podcast.
Perfect. Thank you. Take care.
Take care.
Thank you for listening to the Cause and Effect podcast. If you've enjoyed this episode, please subscribe, leave a review, and share it with your friends. If you haven't done so already, you can join our Discord community. And if you have any questions, feedback, or suggestions about this episode or about Effect in general, don't hesitate to get in touch. See you in the next episode.